All right. Welcome to the September edition of OWASP Vancouver Meetups. This week, our special guest is Lucas Amorim, and Lucas is a senior software engineer specialized in distributed systems and application security with over 12 years of experience writing software and performing code auditing and pen testing. He has been involved in many open source projects, including JRuby, Concurrent Ruby, RKT, and Let's Encrypt. That's awesome. That's my favorite, Let's Encrypt. And he's also got several exploits and security advisory published. I know that he's got some big bug bounties before that he's told me about. And we're very excited to have him talk about how to hack Ruby applications. So without further ado, Lucas.
Yeah, I'm just trying to share my screen here. 1 second. Looks like I'm gonna have to reboot my Chrome. 1 second.
No problem. Take your time. Take your time. And while we're waiting, if any of you are not a member of our OWASP Vancouver Slack, please join. I'm going to share the link and there, join the conversation. Here's the link. And also, we do these meetups once a month on the third Thursday of every month. Please join our meetup group, which I'm sure you're here because you have probably signed up through Meetup. But please share it with others. We want to again spread the word of AppSec around here. So the more people that attend these or know about it, the better. So please share and join our group on LinkedIn as well if you're on LinkedIn. Lucas will reboot and be right back with us.
All right, let's get started. So yeah, my name is Lucas Amorim. Today I'm going to be talking about code review, security code review for Ruby applications. I have spent most of my career writing and reviewing Ruby on Rails applications. So who am I? Right now, currently, I am a senior security researcher at Palo Alto Networks, where I work more on the system level, basically on the Palo Alto firewall, the Linux, doing vulnerability researching in the Linux kernel, and also in the system level, the software that we write. So I've been a little away from application security for the past few months, year. As I mentioned, I have over 8 years of experience as a software engineer. Been doing security researching for the past 5 years. I'm one of the founders and members of the Concurrent Ruby core team, which is we build concurrent primitives for Ruby. Right now, it's being used in most of the main Ruby applications we use in Rails. And also a member of the JRuby core team, where I worked on the JRuby runtime for a while. So Ruby. So right now, I think Ruby is one of the most popular languages it has been for the past 10 years or so, mainly because it's really simple to learn and it's really powerful. Doesn't have the greatest performance, but it's really easy to write Ruby code. And as I mentioned, the language is really powerful because you can create a lot of domain-specific language within the language. So you can create your own, basically your own Ruby inside Ruby. So one of the primitives in Ruby is that everything is an object, right? So everything in Ruby is an object, meaning even like let's say an integer is an object. A function is an object in Ruby. So that's what gives the language so much power, because it can redefine itself during runtime. So basically during runtime, you can override functions, method, classes, anything you want, you can override during runtime, which makes everything really interesting for the security perspective. So one of the most popular libraries in Ruby right now is Ruby on Rails. That's being mainly used. It's been used to write web applications, APIs, and Ruby on Rails is a complete web framework that has been around for a while. It's really good. If you are following, from the security perspective, if you're following all the guides, if you're not doing anything that seems crazy or getting out of the way, like Ruby on Rails trying to push you to write in the direction of writing good code and writing safe code. And we're gonna go over why. So this presentation is gonna be mainly about Ruby on Rails applications. This is actually a smaller part of a bigger presentation that I have been working on, where I want to go over several vulnerabilities in the Rails framework itself, in the Ruby language itself. As Rashad mentioned, I have a few exploits published for Ruby on Rails applications, Ruby Rails framework, and this talk is going to have to be, this next talk will have to be more than 1 hour, because I want to really go deep into showing why the vulnerability happened, what techniques I use to debug to actually understand and exploit it. But this is a much smaller part of the presentation, mostly focused on Ruby on Rails applications, right? One thing I need to mention, so this is not related to my work at Palo Alto Networks in any capacity. This is all from my previous jobs and also from my personal researching. I just need to mention that so I don't get in trouble. So yeah, so we're gonna go over a few vulnerabilities, a few classes of vulnerabilities, and I'm gonna try to show how Rails protects the application against those vulnerabilities. And I also want to give you some perspective as a security researcher going to review a Ruby on Rails application, like a white box penetration test. Basically, you will gonna go gonna dive into the code. So usually, in my experience, at least my experience, every time I'm reviewing a new application that I have never seen before, the first few days I'm always lost, right? Trying to understand how the application is structured and everything like that, and how it works, and you don't really know where to start, and that's usually is really confusing, and I think that's the most stressful and not enjoyable part of the job. So in this presentation, I'll try to give you some directions. Next time you're reviewing a Ruby on Rails application, so where to look. So before going to the next slide, I'll close my column. So I'm gonna go over a real Ruby on Rails application, the lab, and I hope everybody can see my screen. So the two major, when I'm starting to review a Ruby on Rails application, there are two main directories that usually I start from. Actually, three main directories: the app, the config. Two directs, the app and the config. Also, I take a look at the migrations direction, the DB, so I can have a good idea how the database is structured, what changes they have made in the database, and you can even see the evolution of the application by looking at the changes that were made in the database, because the migrate directory has a list of all the changes that were made in the database throughout the time. So you can see fields being added, removed, tables being created, deleted. Sometimes you see data that needs to be in the database being stored in the database, all through the migration. So let's go over one here. Oh, and it's always timestamped, so you can actually see you can actually see the complete history in the right order. So this is a simple migration where they just change the column default, which is really simple. Just change the default value from true to false. So you can start looking at that. It's a good start to understand it. And also, one of the main features of Ruby, it's how it works with how is the connection between the database tables and your models, right? So when you see a definition, a model definition here, which we most likely represent a database, you won't see any field being declared in that model. Open this one up, right? So you don't see fields being defined here. So what Rails does is, during runtime, when your application boots up, Rails match the name of your model with the table name, and then goes to the table and finds out all the fields in that table, and they dynamically create like get and setters in your model. So whatever field you might have in the database, it will show up in your model. You have a function, a method in your model that will have the same name, and then you can set and you can change, you can fetch the value, right? So it's good to have a like a mental model of your of the application by also looking at the models. And the second directory that I look at is the controllers. So controllers in Rails is basically is your endpoints, your web endpoints. So every endpoint will be target, will have its own. So this is a bad one. I'm in the wrong spot, sorry. Let's do one here. Okay, the structure controller. So basically you have endpoints, and every endpoint will match to one of these functions. Right, so if you want to find an entry point of a given endpoint in in the application API, you can go and find the URL, and you can match the URL with the controller and the method name, and then you know exactly what the entry point is. All right, let's go back in here. So one of the first things I look at is session hijacking. For those who doesn't know what session hijacking is, it's when you are able to fetch the session ID from a given application. You might be doing, I don't know, a man-in-the-middle attack, or might be just a cross-script vulnerability, and you fetch the cookie, and then you inject the cookie in your browser, and you log into the application just as the user that the cookie belongs to, right? So one of the things you should do, you should look first in the config directory. There is a directory called environments, and over there you have all the different environments you might have in your usually street production, testing, and development. You should always force SSL to true, which means that cookie will never ever be transferred over plain HTTP. You always have to go over SSL. You can also have that configuration in your infrastructure, but as a developer, as an engineer, if you want to really make sure that that is safe, that you have control over that thing, that nobody else is going to change that, and they might make a mistake and remove, that's a good place to start. I wasn't going to include this, but I'll have to, because recently this year I found a really interesting vulnerability. So the secret key base in the Rails application is basically a key that's going to be used to encrypt a bunch of different things, including how you generate your session ID and how you also generate your CSRF tokens, right? So in the production environment, usually that value comes from an environment variable. I found two cases where there was a misconfiguration in the environment variable in the container that was running, and it wasn't set properly. And actually the secret key base was new, which means was known for me. So I could generate the key by myself because I knew the key was empty, right? So with that being said, and having the user ID, I could generate a session ID for any user and log that in any application that I wanted to, right? So I added this because up to that point, I did not know that, and it was actually when I saw that the value was new, I started thinking about what I could do with that, and then after looking into the Rails source code, I realized that was being used in several different places, and that could be easily abused, right? So just if you review an application, make sure that you have a value in there that is valid. And I highly recommend you to rotate that from time to time. Reason being, once you rotate that, all the sessions going to be invalidated once you deploy again. But if that key leaks somehow, then you'll be in trouble. All right. So when I'm reviewing the controllers that I mentioned before, the controllers receive the HTTP request, is the front line that receives the HTTP request. I always make sure that the protection from CSRF is enabled by default. Because if that's not enabled, then Rails will ignore the CSRF token completely, right? And what happens a lot, and I have seen this happening many times, is you have the same controller that will handle, will respond with HTML or like JSON formats, right? So that same controller is being used for regular HTTP requests and also for API requests. When it's being used by for API requests, usually it doesn't use the cookie, use the token for authentication. Because there is no cookie, that request also accepts, let's say a post request accepts value without the CSRF token because of the API. So the API, usually we don't use that. So they try to reuse the same controller. And then you can easily abuse that by, when you generate your CSRF exploit, your POC, you just change the content to JSON, and that will make Rails say, oh, this is a JSON request. So it might just ignore that the CSRF token, right? And you still have the cookie. So usually they don't check whether the request is HTML or JSON. They just try to find a cookie, doesn't find a cookie, try to find a token, authenticates, and then pass the request down to the controller. The controller says, oh, it's JSON. I don't need to check for the CSRF token. I can just accept it. So that is something that I have seen happening many times in the past. And I think as of last year, I saw that in one big application. Yeah. So again, when you're reviewing the controllers, you should always start from the application controller. That's the main controller, and all the other ones are under that, right? There is another one above that. It's a Rails called base controller. So all the other applications controller inherit everything that's been defined here. And then, as you can see, the very bottom, we have the protection from CSRF. And that protection will be inherited by all the other controllers. Oh yeah, that's a good one. So there is a lot of, so in Rails controllers, you can define filters for every action. You can say, before that action happens, execute this function, execute this method or this lambda, whatever it might be. I haven't seen this with authorization when the user is already logged and you need to verify whether that user has privilege to access that given resource. And a lot of developers, they use filters for that if they don't use one of the well-known gems. Every now and then there are actions that you don't need to check for permission that everybody has access to. Let's say check the index page, right? Every single user has access to the index page. You don't even have to worry about that. So usually they put an exception there, right? Oh, sorry, they put a only, and then they put a list of endpoints that filter should be applied to. But then another developer comes in, write another endpoint, and forget to add that to the list. And then all of a sudden that adds up, and then you have several endpoints that's not being that filter is not being applied to before hitting that. So if we go back here, we can see here that they did well, like requiring email unless the device controller. So so that is that's a good one. We can see on top we see the if. So it's not only except and only, but we can also use if and unless to do that. Oh yeah, as we can see in this the beginning here, they have a lot of, including a lot of other helpers. It's always useful to check those headers, those helpers, to see what they are doing, because as I mentioned before, Ruby is a highly dynamic language, and then sometimes you include a helper, and that helper will completely change the behavior of or every single function in your controller. Right? It's not like, oh, I'm including this header and this helper, and this helper will add a few functions that I can use. No. That's not like that in Ruby. That could potentially change, override functions, override anything in the system, right? And I speak from my own experience. A lot of software engineers, once they discover the power of Ruby, how dynamic the language is and how much they can do, especially with meta programming, sometimes they go a little crazy and they start using that a lot and abuse that a lot. And because it's cool, it looks good, right? Especially when you're doing, I'm guilty of that. Like, code review with your peers, and you see something you did is really cool, use the meta programming, and that you show how much you know Ruby, and that gets sometimes you're getting a little big problems doing that. Right. So yeah. So I always make sure that if you have security checks using filters, make sure that's being applied to every single endpoint that needs to be applied to. And you also need to think about the filter. If I add a new endpoint, does it need to be added here or not? Because if you use the except and that's not being added, there's going to be a bug. You might a user might not have access to that endpoint, and then you might need to fix that. That's no big deal. The problem is when the user actually have access to something they should not have access to, right? So that's a vulnerability. That's when the problem starts. If they don't have access, that's fine. We can fix that. It's no big deal. So always play safe and trying to mitigate that problem. Right. But yeah, for example, here we have rate limiting being applied to a few endpoints, and only being applied to the create endpoint, which means every single one of other one that will not be applied to, right? Which is, let's say you need to apply that to another endpoint, and you add the endpoint, you forget to add the list, to add it here, and that's gonna be okay in QA. Code review, when you're doing code review on, let's say, GitHub, it usually only shows the piece of code you have changed. It doesn't show, especially when you have big files, you're not gonna see the filters up top. So unless the developer know the code really, really well, that's gonna go through the code review easily. That's gonna go through the QA easily, and that's gonna end up in production easily. If it was the other way around, the QA will probably say, hey, this user should have access to this, and they don't have access, so we should fix that. And then that's a much better outcome. Right. Yeah. So that's a classic one. I think it's pretty much similar to almost every single language out there. You never concatenate strings to do with unsanitized inputs coming from the user that you don't trust. Every time I see this in a Ruby or whatever application I see that, I just want to cry. And but like, I feel like I losing 1 year of my life every time I see something like that. Just yeah. So just be on the lookout for that. That's usually on the controllers. You see the code like that. So in this case, the name param is coming from a web request and it's being concatenated directly into a SQL query, which is going to generate a lot of problems. Even though the where is actually part of the Ruby REST, will be concatenated all together when they build a string and when they do the query, and then that's going to be a problem, right?
Lucas, there's a question in the chat,
yeah,
I think related to the previous point, not the SQL injection. How do you know that rules should be applied to all actions? Because not before filters are security rules. What would help us identify them easily?
Yeah, so first you need to understand what the filter is, right? What that filter is doing. And that goes back to understanding the whole application flow and the whole application structure. But usually when you see the only, let's go back there. So yeah, so usually when you see the only in the filter, that's a red flag, right? Once you see the only, that's when you right away you should go and look what that thing is doing and whether that filter should be applied to the other controllers or not, right? It doesn't mean like if I see a except, then I'm like, oh well, the developer actually wrote except and put it in there, so it's probably most likely right. I don't have to worry much about it. It's good to check, but like it's not a red flag. If I see a only and there are other actions in that controller, that's a red flag. And that's where I should go back and look at every single action and see what would happen if that filter is not applied to that other actions. Does that answer your question?
Yeah, thank you.
I think it does.
Yeah, so this is actually a really good example of when you see something like this. I just read through it, like, okay, that's completely different from something like you see a parameter coming from the web request being concatenated to a string. That's a red flag right there. And then when I see something like this, I'm like, well, there is no SQL injector here, unless there is a vulnerability in Ruby in the Rails framework. There is no SQL injector here at all. So if you see something like this, don't even waste your time. Just move forward. You'll be fine. If you see there is only one input coming here, label underscore names, and then it's being used right here. And then when you use the symbol in Ruby with the where, Ruby Rails automatically filters that and make sure that it builds a query that's sanitized. So you don't have to worry about that, right? I know nowadays we have load balances, we have a bunch of other things, and I have seen that a lot where you have your application code and you have the your infrastructure definition, your load balance configuration, and so on and so forth. And then usually you put all the headers and the like Nginx or something like that should be added, but that's not under the developer's control. Usually the infrastructure team is dealing that. And every now and then something gets removed, and then you have a missing header, right? What I always recommend when I am reviewing Ruby applications, like you define all the headers that need to be defined within the application, and then you write unit tests for that. So another thing I always tell the developers, the Rails developers, like every time we talk about something like this, you gotta write a unit test to make sure that thing doesn't break. So let's say default headers. This is something that is not having that is not a vulnerability per se, right? But that's a nice to have. So every time I'm reviewing an application, I'm writing my report, I always recommend them to do this and then write a unit test for that specific to make sure that the default headers are present, because if somebody comes and removes that, right away your test suite breaks and then you know something got removed and should be there, and then you can actually take a look and see whether that actually needs to be there or not. Right, so I always like to define to put them in the application itself. Same for CSP. You can define it all in your application. You can even define them. This is a global configuration that's going to be applied to every single endpoint. You can define specific ones for specific endpoints dynamically. You can do that by in every controller on the application controller. You can do that. Let's say only apply this to given functions. So there's also something that I highly recommend them to do. Yeah, and another thing I like to take a look at is whether we have files with information that shouldn't be there, with sensitive information, right? Even if that file is being injected during the boot time, during the runtime, during the deployment, I always recommend them to remove all the files with sensitive information and put them in environment variables. Reason being, if you have an arbitrary file reader vulnerability, they can go and read that file. They could go and read that file and get all your sensitive information. If you have that information in environment variable, in order to read that, they need remote code execution. And then if they have remote code execution, then you shouldn't be, you're in much deeper problem than that. All right. Something else that I highly recommend is there is this project called Breakman, which is you can run that in your CI/CD pipeline and show you, it's static analysis for Ruby. It picks up a bunch of vulnerabilities, and it's really good. And also picks up Ruby gems with known vulnerabilities, which is super good. So yeah, that's it. Thank you. If you want to reach out, my email, my Twitter account, and yeah, if you have any questions, let me know.
Thanks very much for a great presentation, Lucas. Any other questions? We've got time. Betsy's posted, please provide your feedback for today's talk. Yeah, please do that. We always appreciate feedback. That's how we can make things better. Francois Merrier. Francois, how's it going? Thanks for posting. And yeah, it's a great way to use a file to red vol to read the secrets from the environment variables. Yeah, any questions, comments?
Yeah, I guess so, Lucas. Francois had the similar comment. I think sometimes if you have a LFI, you can read environment variables as well through proc file system.
But do you need root permission for that?
I'm not 100% certain. To read environment of different processes, definitely. I'm not sure about like your own environment variables.
Yeah, I don't think
it's like same process, right? Do you know, Francois?
I don't think you do for the same process, like you said, but some applications will sandbox themselves to prevent themselves from being able to read this kind of stuff, and that's a good idea to do it. But I think the default is to be viewable to the self.
Hey, Farshad, I've got a quick question. So in terms of default headers and default CSP policies, typically within my organization, what we would do is have it at the WAF. And there is the ability to have it like you showed in configuration files that travels with the application. Do you recommend that it at the application level, or is the WAF good enough? Because you did make an interesting point there by saying, just in case, the network guy or the infrastructure guy does a misconfiguration, now all of a sudden you don't have that level of protection. So do you recommend it in both places, or yeah, just what are your thoughts on that?
Yeah, I always recommend to have in both places, just as a fallback solution, especially because the application level has a mention, like you can write the unit test, and if it gets removed, right away. And the reason being, I haven't seen that happening before, where somebody removed a few lines in the configuration file and then didn't go through the developer's review, and then ended up in production, and then you have the problem right there, right? And it doesn't take much to have that in your application, right? Just one more file, and you have everything defined there, and that can save you, a lot of time and headaches. So every time I talk to developers, I highly recommend them to have them both, because having both is not going to hurt you, right? Not having it might.
Just to add to that, when you have, like Lucas said, if you have them in both places, it'll be the intersection of the policy that the browser does. So like as an organization, you might want to say like, okay, we don't allow, I don't know, like images from different domains. But then on your application, if you know that you also don't need scripts from another domain, then you can limit that further and tighten the policy. What you can't do is loosen up the policy at the application layer because it's the intersection of it. So it makes a lot of sense to do what your organization does to set organization-wide policies.
Thank you, guys.
Yeah.
Good questions.